Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's figure 1, figure 2, figure 3. Your challenge is to predict the number of stars in figure 4. If you can do that, can you predict the number in figure 43? And can you write an equation that could be used to predict the number of stars in any step at all? So that's the challenge. If you'd like to accept it, pause the video, see how far you can get. Well, I'm very curious what your initial impressions are in looking at this one. I see some lines that get thicker, so we've kind of got lines of stars going up and down and some going left to right. So I guess they form rectangles, and those rectangles are getting bigger. So my first thought is that this is probably quadratic. So I think what we should do is analyze this pretty closely, look at all the numbers, and see if that hunch is borne out or not. Do you have a prediction? All right, well, let's see what we've got. I think, what I'm going to do is look at these up and down ones first and ignore the rest for now. And then let me just count how many there are. So 2, 4, 6, 8, 10. So that's 11 just in that up and down. So this part is 11. And what about this? That's also 11, but we've got two of them. So 2 times 11. And here we've got 3 times 11. So it looks like just for this part of the pattern, we're taking the step number and multiplying it by 11. So that's pretty simple. And then I think for the part that's left over, I'm going to ignore this one, just leave it out for now. We'll add it in at the end because that seems to show up in every single one. Now let's just look at these rectangles. So I've got 2, 4, 6, 8. Oh, so that's 11 long as well. So this part is 2 times 11. And just double check. Yeah, those are still 11. So we've got 4 lines of those. So it's 4 times 11. And let's see, now it's 6 times 11. So it looks like I've got, 1 times 11 plus 2 times 11. That would be 3 times 11. So that's 33 in figure 1. Let's make a little chart while we're at it. So we'll have the figure number and the number of stars. So in 1, there's, not 33, plus 1 is 34, right? Got to remember the plus 1. Okay, so 34. Here I've got 6 11s plus 1, so that would be 67 stars. And here I've got 9 11s, that'd be 99, plus 1 would be 100. Can we predict step 4 now? So the first part will be just 4 times 11, right? Because we're going up by the step number. 1 times 11, 2 times 11, 3 times 11. So for figure 4, we're going to have 4 times 11 for the up and down part. Oops. And then, let's see, we went 1, 4, 6. Oh, so that looks like, 2, 4, 6. So that looks like the step number times 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. So I think we'd have 8. So 4 times 11 plus 8 times 11. So that's 12 11s and one more. So 12 times 11 would be 132, plus one more would be 133 for step 4. So that's my prediction for step 4. Do you agree with that? So let me add the plus 1 here. All right, now let's go ahead and analyze these numbers because I think you may find this a little bit surprising, perhaps. So 67 minus 34, that's 33. And 100 minus 67, 33. And 133 minus 100 is 33. We've got a constant in our first set of differences. That means this is a linear pattern. Even though we have rectangular shapes and they appear to be growing, the rectangles are only growing in one dimension. So this rectangle is only getting wider every step. And this rectangle is only getting taller every step, but they're not getting taller and wider at the same time. If they were, it would be a quadratic pattern. But because they're only moving in that one dimension, only growing in that one dimension, it remains linear. It is a big linear pattern. So we've got first, this first part is the step number times 11. So that first part is 11x. And the second part is the step number times 2 times 11. So 2 times the step number times 11. So that would be, 11x plus 22x. And then we've just got this 1 hanging out So that gets added. So 11x plus 22x would be 33x plus our leftover 1. So that, I think, is going to be our equation. And that came right out of this sort of visual analysis that we did. But if you want to plug the numbers back in here, in step 1, it would be 33 times 1 plus 1. That would give us 34. In step 2, 33 times 2, that'd be 66, plus 1 would give us 67. So you can check it out with more steps if you like, but I'm satisfied that this equation is correct. I think that's the first time we've ever had a coefficient of x be that big in one of these patterns. All right, so all we have to do is plug 43 in for x to figure out the number in figure 43. So that would be 33 times 43 plus 1. Let's see, 33 times 43, I'm just going to punch this one into my calculator. That's 1,419 plus 1 would be 1,420 stars in figure 4. Well, how did that go for you? Did you get 133 for step 4? Did you think, like I did, that this might be quadratic at first, or did you see right away from the beginning that this was going to be linear? Let me know. Thanks, everybody.